Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Senpai. Welcome back, everyone. Today we're jumping into a sixth grade topic, building equations with multiple independent variables. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today or even your own homework, you can always visit my Facebook page at Tutor Me Senpai and tell me all about it there. This video will have two parts, so leave a like, smash subscribe, and let's get started. So in today's video, we're going to be taking a deeper look into our equations. And by doing that, we're going to be focusing on equations that look something like this. This type of equation looks very different from what we've been covering on this channel so far. Now, if you haven't seen any of my other videos on equations, no worries. I have all of them linked in the description box below. If you look below, you'll see stuff on equations versus expressions. You'll see what is an independent variable versus a dependent variable. You'll see how to even build your equations from not only your word problems, but also pictures. So if you need a refresher, go check that out. Or if you're new to the topic, go check that out before you look at this, because it takes a good understanding of what an equation is before you can start building on it. So make sure you get those building blocks down first. Check out those videos and then come back to this one when you're ready. But after all of those videos, you're pretty used to seeing something like this, where you have one independent variable and you have one dependent variable. But we want to today look and see how we can evolve our thought process around having an equation with just one of each to have an equation where you have many independent variables to one dependent variable. Now, it's important to note, you can't swap this. You can't have many dependent variables and one independent variable. You can't have more than one dependent variable if you only have one equation. If you have one equation, you have to have a maximum of one dependent variable, and it's typically by itself. You can have 1, 2, 3, 4, however many independent variables you want, because you control those. You tell those variables exactly what they need to be. And by doing that, you can figure out what your dependent variable is. But if you have multiple things that you don't necessarily know, it's going to be hard to find one or the other. So we can't have multiple dependent variables, but we can have multiple independent variables. So we're going to be checking out how we can do this with our first example. We're going to see what does it mean to create an equation with multiple independent variables. So in our example for today, we have Greg who wants to buy some clothes. And we know that shirts are going to cost $9.75 each, and pants are going to cost $12.50 each. And we want to write an equation to represent the total cost of the clothes. Greg wants to buy a certain amount of shirts and a certain amount of pants. So let's write an equation that shows how much that's going to cost him. So remember, we're going to first start off by identifying what our independent and dependent variables are, and then we'll put it together for our equation. However, we have some numbers here. So let's first identify what those numbers are. So we have 975 and we have 1250. Are any of those going to be our independent or dependent variables? No. 975 is a constant. 1250 is a constant. Those are not variables. They're not changing any. This cost is a fixed cost per item, right? So this cost is not changing. However, what is changing? What is going to potentially move around as either we see fit or the equation sees fit? Well, Greg wants to buy some clothes, and it seems like he's going to buy some shirts and some pants, which means he knows exactly how many pants and how many shirts he's trying to buy. However, that number can fluctuate. Let's say he goes in with the intention of buying 3, but when he gets in there, he finds one that he really likes. So now he buys an additional one. He controls how many shirts and how many pants he wants to buy. He doesn't know exactly how much it's going to cost, but he does know exactly how many he's going to buy. That means that shirts and our pants are going to be the independent and their total cost is going to be the dependent. So we'll say S for number of shirts, and we're going to say P for number of pants, And we're going to say T for total cost. S is going to be the number of shirts that he's going to try to buy. P is going to be the number of pants that he's going to try to buy. And T is going to be what the total cost is once we put it all together. Okay, now that we have our independent variables and our dependent variable, let's put it all together and try to create this equation. So we're going to do like we always do, and we're going to keep our dependent variables separate from our independent variables. So a T is going to go on this side, and we know we have an S and a P. So we have an S, and we're going to have a P. Now we have to figure out where do the constants go, or in this case, the coefficients go. Let's make sure we're putting them on the right variable. We have shirts costing $9.75 each, and we have pants costing $12.50 each. So where's $9.75 going to go, and how is it even going to look? Well, we know that each shirt is going to cost $9.75, so we're going to be multiplying this $9.75 by every shirt that he tries to buy. Therefore, $9.75 should be multiplied by this S. $9.75 times S. And we're going to buy pants. So that's not going to be subtracted from how much your shirt's going to cost. This is in addition to. So we're going to add $12.50 times the number of pants that we buy. So when you look at this, you see that T is going to equal $9.75 times the number of shirts plus $12.50 times the number of pants. And this is going to be your equation that has multiple independent variables. You control what S and P are, but you don't necessarily know what this T is going to be. This is going to be our dependent variable. It's going to depend on everything else over here. You don't control this. So I hope you were able to follow along with today's example, and hope you now see how you can create your equations with multiple independent variables. Just make sure that you don't swap them and try to have multiple dependent variables. However, if you have any questions about what you saw today, or even your own homework, you remember you can always visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave a like. It surely helps the channel by letting YouTube know that you found this video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping to help with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this has been another session of Tutor Me Sempai.